Okay, lads, right. Today we're looking at glaciers from the point of view of short questions in part A's. Again, if we're doubling down on physical geography, you need to make sure that you know your short questions in part A's. So you don't need to know much information in detail here. The main bits we cover here, you do need to know just in case they do pop up in short questions or part A's. They do come up quite commonly. So these are the things we're going to cover. What is a glacier? The process of glacial erosion, features of glacial erosion, features of glacial deposition, and features of fluvio-glacial deposition. Wherever you see the word fluvio-glacial, it means river or meltwater in this case. So basically the water that's coming from the melted ice in the glacier and how that causes deposition to occur. Okay, so moving on here now, first off, starting off here, what's a glacier? So a slow moving river of ice, as you can see there in the image. That's what it is. The snow gets squashed into ice, it slides downhill under its own weight. So high up in the mountains, snow accumulates in cracks and crevices. It gets squashed, compressed, compacted, and turns into this slow moving river of ice, which moves down slope under its own weight. The friction between the ice and the ground creates heat. The heat melts the ice. The water that's created by the heat acts as a lubrication that allows the glacier to move down slope. Okay, and the glacier will always take the easiest path. It will usually follow the path of a river that might have been flowing through the area already. So basically what's important here, how the glacier moves and what it actually is. They're the two most important points there from that. So, you know, it's up to you what you want to take down here or not. I'd advise you get some of this stuff down though, so I'll leave it here for a second or two. Next up, this is really important. This comes up time and again for the part A, is the process of glacial erosion. You'll see here we have two different processes. We have plucking and we have abrasion. Okay, there's a little link there. I might put it up later on and separately as to how glaciers move. But basically, plucking occurs when glaciers move. They cause friction. The friction creates heat. The heat melts the ice. The ice creates water. Well, that water gets in around the cracks into the ground and refreezes. Okay, when the glacier moves, it plucks the rocks out. That's the process of plucking. So once you have these rocks plucked out of the ground, they're stuck to the bottom of the glacier. As the glacier continues to move, the plucked rocks scrape the landscape over which it moves, kind of like the studs of a football boot. So imagine you've got a football boot. The studs at the bottom of the football boot, they're like the plucked rocks. And if you take your football boot and rake it across the ground, that is your process of abrasion. So it has this sandpaper effect. And it creates these scratch marks called striations. And that's what allows the glaciers to shape the landscape. So they are the two processes of erosion. Now these are, you know, if there was anything you're going to take down, those two things that you see there would be it. This one really important as well. It's really important that you can recognize features of glacial erosion, deposition, and fluvio-glacial. Very often you'll be given a picture or a series of words and you'll be asked, to match them up. Are they, features of erosion or deposition of glaciers, rivers, sea, whatever it might be. So these are the different features and parts, and this slide is really, really important. And it's really important that you can pick these out in pictures and on a map and on a diagram. You'll see that in the series of questions at the end. They're the different types of questions that are really most common here. Okay, so we're going to go through all of these, just pointing out what they are, what they look like, where they might be found in diagrams. So first of all, these are our features of erosion. It would be a really typical question for you to have to answer. Would be to label a diagram like this. It would be really, really typical. So they are the different parts, and we're going to go through all of these different parts. We'll give a definition for each one, and we'll show you what they look like in pictures and maps if it's appropriate. It might be no harm for you to sketch that in. So we'll start by recognizing some of these features. Truncated spurs and hanging valleys. What are they? Well, truncated spurs, they are the cut off former interlocking spurs. So here's a truncated spur, here is a truncated spur, here is one. Formerly this used to be a V-shape or a V-shaped valley with interlocking spurs. The river had to wind to get around the hard rock. When the glacier arrived, it simply plowed through that hard rock and created a big wide valley. Okay, so that's what our truncated spurs would look like. Hanging Valley is a smaller tributary valley glacier that joins a larger one. So you can see here, this would have been a smaller glacier, it feeds into a larger one. Okay, and that's what it would look like on a photograph. Next up is our U-shaped or glacial valley, glacial trough. You can see it's a U-shaped valley. Why? Wide, broad floor valley, valley floor, steep sides at either side. You know, that is your characteristics of your glacial valley. What would it look like on an OS map? Well, you've got your contour lines packed tight together at either side, wide flat floor in the middle, possibly a river flowing through it. That would be what we would refer to as a misfit river. It's a misfit because the river is not big enough to have created this valley. It had to have been created by glaciers. You can see a misfit river here in this one. Okay, that's how you recognize it on an OS map. The U shape as well, the misfit river. Another feature that comes up from time to time is a fjord. A fjord is basically a drowned U-shaped valley, linked there as well to isostasy. Next up, we have our ribbon lakes. Paternoster lakes can be referred to as either. So basically, in the floor of your U-shaped valley, you may have a series of lakes, you know, joined together by a river in maybe a rosary bead shape, hence the name Paternoster. How would you recognize them on an OS map? You know, you've got your big lakes within the U-shaped valley, as we can see there. So there are a series of narrow connected lakes found in a U-shaped valley. Next up, we have your Cirque or Corrie. Cirque, Corrie, Coombe, all the same name for the same feature. Basically, it's a Cirque, Coombe, Corrie is the birthplace or the beginning point of the glacier. Snow accumulates here, compacts, gets squashed and moves down slope under its own weight. We see a lot of these in the south and southwest of Ireland. This is what they would look like on your Ordnance Survey map. So you can see here that you've got your contour lines packed closely together on three sides. One side, contour lines are spaced wide apart. Glacier began here and moved in this direction. Okay, so you know, Cirques or Corries can tell us valuable information about the way in which a glacier moved. Here you have Cumshigon in County Waterford. You can see this surrounded by steep sides and three sides. One side is open, glacier moved down the open side. Okay, so they have an armchair shaped. In other words, it means it has three steep sides and one open side. So if you think of your armchair, okay, that you sit on at home watching your Netflix, okay, there's your armchair, three steep sides, one open side. Okay, glacier moves this way. May contain a lake called a tarn. Not all of them have tarns, most of them do. An arête is a steep-sided knife-like ridge that separates two cirques or two U-shaped valleys. Okay, so there's your arête right there, and that's what it would look like on your Ordnance Survey map. Pyramidal peak or horn, three U-shaped valleys or cirques or combes form back to back. You're left with this peak. Okay, and that's, you know, that's all you have to basically be able to recognize on your short questions. So again, this would be typical. Pick out the different features. Cirque or tarn, there they are highlighted there in that. There are my cirques and tarns on my Ordnance Survey map. Next up, the hanging valley. How would I recognize that? There you go, there's the hanging valley. Smaller glacial valley meeting or joining up with a main one. U-shaped valley and Paternoster lakes. Well, you can see the U-shaped valley there, wide floor, steep sides, series of interconnected lakes flowing through it. Next up, my arête, my pyramidal peak, and my truncated spurs. So my truncated spurs be found here, here, here. Here's my arête, and here is another one, and here is a pyramidal peak. Next, features of glacial deposition. Anything that's carried and dropped by a glacier is referred to as a moraine. There are different types of moraines depending on where the material is dropped. Material dropped at the side is a lateral moraine, dropped in the middle, medial moraine. A temporary point that marks, you know, maybe the end or the advancing point of a glacier is known as a recessional moraine, and a terminal moraine marks the farthest point that a glacier has reached. So that's just, again, something to do with the material that's dropped by the glacier. Next up, Drumlins feature of deposition. They're small little hills of boulder clay grouped together in swarms, often referred to as a basket of eggs topography. You have one steep side and you have one gently sloping side. Again, Drumlins can give you an indication in terms of what way the glacier has moved. The glacier hits the steep side first, and then it smoothens out the other side, making it a wedge shape almost. An erratic, large boulders or stones out of place with the rocks around it. And there's your final feature of glacial deposition. Next up, we're on to our fluvio-glacial features of deposition. So again, from the melting water of a glacier, several features here are only created by the melting ice of a glacier. First one we're going to look at here is our outwash plain. And again, the outwash plain is the area in front of the terminal moraine that the meltwater, the flood waters from the melting glacier literally flow into. So it's deposited with lots of, or it's got a lot of, moraine deposits, boulder clay deposits on it. Larger boulders are deposited first, smaller materials are carried further. Makes sense. One of the other big features you have associated with fluvio-glacial deposition is an esker. An esker is a long ridge of deposition that was carried under a glacier by a meltwater river. So basically, as the glacier was moving, friction creates heat melts the ice creates water. That water collects and collates together to form a river that flows underneath the glacier. Rivers carry material. When the ice is gone, the glacier is gone, there's nothing to move that material. It builds up into a ridge known as an esker. And you find those in areas where glaciers would have moved through. Kettles and kames. A kettle is a hollow, often filled with the lakes. Again, it's found in the outwash plain, a series of them together. And a kame is a conical mound of basically boulder clay, boulder material. How is it different from a drumlin? Well, a kame is conical, it's not wedge shaped, and a kame usually occurs on its own, whereas drumlins are wedge shaped and they occur in groups. Again, it would be important that you can recognize all those different features on an ordnance survey map, mainly your erosion ones, but there can be a few deposition ones that might pop up from time to time. This would be the series of questions that have come up. You can have a look and find these yourself in your exam papers and have a go at those practice, but you will see that they do come up quite a bit from time to time. That one from the mocks, this one here is in the mocks as well. This one here came up in 2019, it was a 20 marker question. This one was in 2017, this one in 2015. Okay, so plenty there to revise on and keep it going for today's class. Okay, hopefully we'll be back tomorrow. Okay, talk to you soon. Bye.